Okay, so we have 5.44, and in the picture we have two 100-kilogram blocks connected by a rope. The second rope hangs beneath the block B here. Both ropes have a mass of 250 grams, or in other words 0.25 kilograms. The entire assembly is accelerated upward at 3 meters per second squared. We want to figure out the overall force, the tension at the top of rope 1, the tension at the bottom of rope 1, and the tension at the top of rope 2. Definitely need a free body diagram for this. Okay, so I just called them mass 1 and mass 2. They're the same thing. Mass A, mass B, whatever you want to call them. They're each 1 kilogram. The mass of the rope is 0.25 kilograms, and we're accelerating upward at 3 meters per second squared. And we've got to find several things. For the system, here's the free body diagram of the system. We have the first mass, the rope, the second mass, the rope. So if you just looked at these as a system, the tension in between here, that's an internal force. We're just looking at the actual forces, just pretending like this is just one object. So the free body diagram for just one object would be this outside force F up, and then the weight of the system down. Don't forget the weight. The weight of the system is the total mass of the system. So the mass of the system would be 1 plus 1 plus 0.25 plus 0.25, so 2.5 kilograms. And we're trying to figure out this force. There's no formula in the book for the top force for this situation. We've got to create a free body diagram that includes that force, and then use Newton's second law to hopefully figure out that force. And this is Newton's second law. The net force is ma. In this case, the m is the mass of the system. And then you look at the free body diagram to fill in this part. The actual force is acting. So we've got F up, weight of the system down. A little bit of algebra. This force we're looking for would be mass of the system times A plus weight of the system. And then the weight of the system is mass of the system times G. And this is how you can get the outside force on the system. For part B, we want the tension at the top of rope 1. So we're going to have to think about where that force is acting. So it's actually acting on mass 1 here. That's really what's sort of trying to slow mass 1 down. It's this tension this direction. I mean, ultimately that tension is because it's lifting the second block, it's lifting the rope, lifting itself. But when you just look at the free body diagram of mass 1, here's what we have. So we've got this outside force F lifting up. We've got M1G pulling down. And then the rope, tension always pulls away from the object. So we've got tension at the top of rope 1 here pulling down. And then we could use Newton's second law. Net force, M1A. And then look at the actual forces. That's the part where you have to supply the information. We have F up, that's this external force. We have M1G, the weight of mass 1 down, and then minus tension top 1, which is also pulling down. And then the only thing we don't know is tension top 1. So I can take this, move it to the left-hand side, M1A, move it to the right-hand side, and then finally I get this for tension top 1. Okay, then we need the tension at the top of 2. Sorry, the tension at the bottom of 1 first. Okay, so let me do the free body diagram of the rope. This is the top rope here. This rope in the picture. So we have tension top 1 for the rope pulling upward. We have mass of the rope, G, just the weight of the rope. And then we've got the tension bottom 1 pulling downward. Okay, and this is the one we're trying to find. Now we know this one from part B. This is mass of the rope times G. Use Newton's second law again, net force, mass of rope times A. And then you again have to supply whatever goes in this box from the free body diagram. Top of tension 1, that's up on the rope, minus the tension at the bottom of 1, and then minus mass of the rope times G. Now for part D, we're trying to figure out the tension at the top of rope 2. So I would, for part D, and I'll leave this to you, do the free body diagram for mass 2. Put all the forces on, go through the same procedure with Newton's second law. You'll see that the only thing that you don't know is the tension at the top of 2. You could also do the free body diagram of the second rope and get the same result. Okay,